Thank you very much. It's an honor and a privilege to be able to share my views and our views with this group. And I think Tesla has a unique position and a unique vantage point on what's happening regarding innovation in the transport sector. We're in the midst of it, and we've been part of helping drive that from our point of view for the number of years since we were founded. And in particular, our goal, our really clear focused goal at Tesla is to accelerate sustainable transportation in all different modes with all different players around the world. Right now we're very focused on electric mobility with passenger vehicles, but broadly we see this as a need that can span across the whole transport sector. And I can definitely echo the comments that this is probably one of the most exciting times that I can think of to be involved in innovation in the transport space. I can't imagine a time in recent decades when there was more technology change, there was more rapid business innovation, more new entities, and generally just more excitement about the future and all the different things that are happening. Maybe 100 years ago, perhaps, when the whole modes of transportation were being reinvented. And today I'll sort of discuss with you three main innovation forcing trends that I think are the key events pushing what's happening today and into the next several years. The first is the changes that relate to electric propulsion technology. Broadly, this is the class of technologies that are pushing innovation not just into passenger vehicles, but into freight, into trucks, and potentially ultimately aircraft as well. Environmental pressure. This is an overlying theme that is not going away, and it's really inevitably increasing in every single region. And is going to change the face of transportation in all these different sectors. And finally, autonomous technology. This is a bit more recent, but is actually improving and changing even faster than what's happening with electric mobility, and is going to have similar wide-reaching effects. And it's really the two first themes that I mentioned, the changes in propulsion technology and the ever-increasing environmental pressure, that were the two themes that Tesla was founded around 13 years ago. Those two premises were what we initially looked at and followed those trends into the future to see that, from our view, electric mobility was going to continue increasing and going to be continually more relevant, as battery technology improved and as environmental regulations continued to be more strict. And to focus for a second on those improvements in electric mobility technologies, batteries are the thing that gets talked about by far the most. And it's with good reason. Batteries have the most leverage, they have the most impact on cost and performance of any type of e-mobility. And they're also quite exciting because today's batteries are nowhere near the limits of physics or the limits of performance capability of what can be invented. We can look into science and understand that much better batteries are possible. We just don't quite know how to make them or industrialize them yet. And in the last few years, it's been the migration from lead-acid batteries to nickel metal hydride and today to lithium-ion batteries that has really laid the groundwork and made possible companies like Tesla Motors and the hybrid vehicle efforts, plug-in hybrid vehicle efforts from many OEMs all around the world. So it's this chemistry innovation and this material science innovation that has the chance to most rapidly keep change driving in the e-mobility sector. And we're also seeing a really interesting shift in the scale of battery manufacture happening. Lithium-ion as a technology class was invented for consumer electronics. It was not invented for transportation. It was invented to make better laptop computers and cell phones. And the manufacturing methods and the scale were all related to the electronics industry. And only today, and in the last maybe 1 or 2 years, have we seen that start to shift, where the manufacturing methods, the scale of operations, even the scale of R&D surrounding batteries and lithium-ion in particular is starting to increase to the automotive level and to the energy storage level for the grid. And this is having a profound effect on the cost and the rate of decline of the cost. For the past decade, that was driven by, again, these consumer electronics industries, and now it's on a new curve, a much more aggressive, much steeper growth curve that can yield faster rates of reduction in cost. We're also seeing performance improvements in batteries, not just cost declines, but also performance improvements, where we can store more energy in the same mass of materials, more energy in the same volume of materials. And ultimately, for e-mobility, range ends up being the biggest defining criteria for passenger vehicles and freight vehicles as well. And to achieve affordable range, we need higher energy density. Those are the two characteristics that are most closely linked. And today, the battery cost is really defined by the material cost that goes into those batteries. The nickel, the cobalt, the aluminum, the copper, the raw materials making up that battery. And if we can increase energy density with increasingly focused R&D, we can reduce the overall materials needed to store a given amount of energy and therefore reduce cost. So all of those different characteristics are very closely linked. And finally, recycling is another area that's seeing rapid innovation. This is something most customers ask us about, but it's not always that intuitive, the amazing recycling opportunity that exists with batteries. All of the materials, when a new battery is built, the materials that are mined and processed to make a battery are still there at the end of the battery's lifetime. And there's a new industry that's yet to be created, which is really a reprocessing industry for all of this energy storage devices, all of the batteries that are going into e-mobility, to reprocess them, to refine them back into new refurbished batteries. We see this at a small scale with lead-acid batteries in the vehicle fleet today, but it will be a much bigger industry in the future with the main batteries propelling vehicles. There's also similar improvements happening in power electronics. The actual power devices used to control the energy flow from batteries into the motor and to move the vehicle. Controls, software, and computing are creating massive improvements in efficiency and the smoothness and usability of these type of systems. And finally, electric motors are also seeing fairly rapid improvement. Although in this case, electric motors are a little closer to the limits of science and the limits of physics. So I don't expect we'll see as dramatic of improvements coming from that area. And so the second main point of pressure on this whole region, the environmental pressure, I don't need to say much about that. I think everyone here is very well aware of the environmental forces pushing on the transport sector, both local and global. And I think we can also all agree that those pressures are just going to continue to increase as these problems become more pressing. But perhaps the more, in some ways obvious statement is that we don't yet have a good solution to simultaneously meet the demands of local air pollution, global CO2 pollution, and products that customers really want to purchase and want to buy. And e-mobility has this great opportunity to answer all three of those questions simultaneously. We can create products that have an enormous customer pull, excitement, and appeal from the public that wants to buy those products, and we can solve the environmental concerns, both global and local. And this is a fairly unique set of technologies that can answer those problems simultaneously and increasingly do it in an affordable and accessible way. And to the third class of technologies, autonomous technologies. This is something that has really, I think, come into the market quite quickly. It was a bit unexpected by a lot of different OEMs and suppliers. And the improvements happening in this space are phenomenal. We can literally measure them in months instead of years. And the major areas are really around sensors, the sensors on the vehicle that are interacting with the outside environment, bringing in data to the car computer. And then the actual computer itself, the cost and capability of mobile computing that's needed to process the data coming in and to make decisions about how to control the vehicle as a result. And finally, software. Autonomous vehicles are mostly defined by the software that operates them, even more so than the computers or sensors that are on them. Fundamentally, in the limit, we see sensors mainly becoming cameras. And a computer that's watching a camera and then trying to recognize the images it sees is a very difficult software problem. And today that's where at Tesla we have a large team of software developers focused on image recognition and understanding those aspects, and also how to control the vehicle appropriately based on that. And I think it's ultimately inevitable that we'll see autonomy playing an increasing role in the transport sector. The trends here are irreversible. We're not going to see them slow down or stop. And full autonomy ultimately will be achievable from a hardware capability point of view much sooner than most people expect, in a matter of years, not decades. And the way that we see this playing out in the regulatory market and in the user space is going to be driven mainly by safety. I think that will be the main application that makes this accessible and makes this something that is regulated into certain markets. It's a simple fact that we can measure today that autonomous systems running on computer control with good sensor input are much safer, more repeatable and safer than a human driver. And as we achieve more and more miles and more data that can demonstrate this with increasing levels of proof, I think we'll see more and more acceptance and ease of adopting autonomous vehicle standards and regulations. This is also driving a whole series of new business models, and the innovation around the autonomous vehicle space is phenomenal. I'm based in San Francisco in the Silicon Valley in California, and you can go not more than maybe 2 or 3 miles in Silicon Valley and encounter some new startup company that's working on an autonomous vehicle, software related to that, or some part of the ecosystem about autonomy. It's a pretty exciting time. And finally, I think we're going to see an increasing level of growth in these upstart companies. Tesla is an early example of success in this industry, but many other companies are following Tesla. There's hundreds, literally thousands of other startup companies working on innovation transport. And the nature of a lot of the technology of these new problems is not the same as the nature of the technology that was addressed in many cases by large OEMs. Maybe Bombardier is an exception, having an early history in electrification. But in many cases, large car companies or truck companies are not focused on software. They're not focused on sensors or batteries. And this gives an opportunity for innovation with new companies and new entrants to play on a bit more of a level playing field than there ever was in the past. And also addressing the more inclusive aspect of electric mobility and electric transportation. Many people have a mindset that electric vehicles today are more expensive, must be more expensive, and will always remain that way. But the interesting aspect is that the cost of operation is the lowest of all different forms. The cost per mile for an electric vehicle is far more compelling than any fossil-fueled vehicle if we're comparing apples to apples. So the main point to address is the upfront cost. How can we reduce the purchase price of these vehicles? And with Tesla, we've put enormous pressure on this from battery cost industrialization, through economies of scale and innovation. And just recently, we launched our newest vehicle, what we call the Model 3. And the market reception for this vehicle, which is priced at about $35,000 US, has been phenomenal. We've seen market interest and actually orders coming into the company that vastly exceeded our expectations. We launched this a few months ago in California, and today we have nearly 400,000 reservations for this vehicle. This was demand that was definitely more than I think anyone in the industry expected, and it proves incredible draw from the consumer and from the public for full-function EVs at an affordable price. And what affordable means, it varies, of course, based on who you are and where you are. But the cost of operation, can close the gap of initial affordability by a pretty wide margin. Depending on the cost of fuel in different regions, that can account for perhaps as much as a third of the overall cost of a car like the Model 3. And overall, our future vision is that ultimately all ground vehicles are going to migrate toward electric. This is perhaps a controversial viewpoint among some different industries, but the trends we see in energy storage, fuel cost, environmental pressures, more or less make this inevitable. If we want to achieve the CO2 goals that we have as a global society, we have to do this. And we also have to find ways to power this with sustainable energy. This is the other critical piece of e-mobility, is where does the energy come from, and the two need to be linked, I think, in their thinking. So overall, with that, I'll close and save time for any questions you might have. Thank you.
Thank you very much for that presentation. Questions? Let me pick up some questions then, if I could, before we move on with the programme. On your last observation about being pleasantly surprised by the uptake and the number of reservations, you now have, of course, the enormous industrial challenge of this huge success. How do you cope with that, given that it was beyond your expectations and you need to find the industrial process to deliver, and I guess, some reasonably short time period?
Yeah, that's a good question, and it's been a point of a great deal of focus inside of Tesla. It's a wonderful problem to have. I think many industries, struggle with their biggest risk being demand of a new product or a new technology, and in this case, we have the opposite problem, which is more demand, and we can put our focus on production ramp up, supplier ramp up. And this is a challenge, not to understate that, but it's a very high-class problem for us to have, and we do believe that we can accelerate this. We've had close meetings with all of our key suppliers and with many of our internal production and factory managers, and we see a way to nearly double the previous plans we had for production rate increase and production ramp up.
By all the standards of what you've described to us, clearly this is, in a very positive sense, a disruptive moment in what was a very traditional industry. You've given a sense of your vision of the future as likely to gravitate towards all electric. What is your read of what I might call the Tesla effect for OEMs, for the original equipment manufacturers who have tooled up for internal combustion engine?
Well, I think many OEMs are beginning to see the level of demand, and the example that Model 3 has set, is not unnoticed, of course, within the industry, and it will have, I believe, a strong effect on future planning amongst large OEMs, and I think most companies are now taking electrification much more seriously than perhaps they would have otherwise. And even the Model S, I believe, was a very strong data point for the entire industry that the technology could be made into a product that would have wide acceptability and could actually be quite commercially successful. Prior to Tesla, that was definitely not well accepted. In fact, I think it was quite widely dismissed. And we still encounter many companies that will dismiss this. I would say electrification is not yet a common viewpoint in the whole industry, but it's certainly becoming more well-regarded and well understood.
Turn to you, JB. It's the standards question, but perhaps in reverse. If we expect in a traditional sector lots of standard setting because the public policy makers are used to dealing with the sector, much of your innovation is so far out in front of what we know. I guess you're writing your own rule book because no one has yet caught up with you as to what the rule might be.
This does present a challenge sometimes, and we often find ourselves in the position of working very collaboratively with many of the regulators, helping to define the early standards and what they should be, how they should be framed. Whether this was around lithium-ion batteries and their regulations, or safety testing, certification, even shipping. We've played a pretty active part in all of those roles, and I think increasingly now, charging standards are definitely an area of great focus, and it's not yet something that I think is widely standardized. Perhaps it's a bit of an oxymoron, but we see completely different approaches to this in really every continent around the world. And China has, of course, a very focused approach. The European Union has an approach. North America has its own approach. And this is one area where we're trying to do our best to work with all the different regulators and standards. But as this continuously evolves in the midst of us ramping and delivering more products, that can be a very challenging environment, both for us and also for the consumers that are trying to use their vehicles amongst an ever-changing standards environment.
My question and my urge was just, first and foremost, engage with us in UNECE and the Inland Transport Committee come next year, 70th anniversary. help us to build this regulatory framework. And the question was, what do you need from us to really move forward? Thank you.
So what do you need? I pass it back to both of you. Who wants to start? JB, you're off first. Okay.
Well, I think maybe I'll address it on three different fronts. Autonomous driving and the regulations and standards around autopilot is one area where having more clarity and more unity would certainly help. The cars are naturally moving amongst a lot of different regions, and right now we see definitely a patchwork of different approaches. And there also isn't a clear standardized roadmap on how a manufacturer should engage, to demonstrate the correct safety or the correct systems. So I think the first step would be creating a roadmap and a framework for gathering of data, sharing of data that many different people could agree upon. That would be a very helpful first step. On the charging standards side, this is again one that I think is a very challenging space, and I would urge regulators to look at the consumer and really what they're able to do in their markets and what's being done today. I think a lot of approaches have taken somewhat of a clean sheet of paper and have left perhaps a little bit stranded some of the existing consumers that were the earliest entrants into the space. And also trying to find even more unity between different regions would be quite helpful. That's something that creates definite challenges at the borders between these regions, or for manufacturers that are shipping product worldwide and trying to comply with multiple standards there. And thirdly, I would look at broadly incentives for driving behavior and adoption of these technologies. There's a wide patchwork of different incentive structures, and some much more effective than others. I think the ones we've seen that work the best are in some ways related to maybe the non-tangible aspects or non-monetary aspects. We were discussing this just earlier, but in Norway, there's a very, very effective incentive structure that gives access to bus lanes and preferential parking, in addition to monetary aspects. But those type of incentives there have driven some of the highest electric vehicle density anywhere in the world. It's a phenomenal market, and they've seen amazing growth. And I think if we can find ways to replicate similar successful incentive structures, that would really help the market.
Could I ask JB from Tesla a question? You talked about what you do with the batteries at the end of their life, and you say you would melt them down and make new batteries. Of course, one alternative would be to use those batteries which maybe have declined in efficiency in static locations to help even out the unpredictability of renewable energy supply. But I wonder if you've taken that one stage further, because you will have a lot of customers around the world who have downloaded cheap electricity at night when the wind was blowing, or maybe in the daytime when the sun was shining, who maybe don't need their car on a particular day. Have you looked at how they could then upload that electricity to the grid to help even out the unpredictability of supply from renewables and actually become electricity traders using their car as the bank?
Yeah, two good questions there. We have a whole separate business unit at Tesla that we've launched that uses the same architecture of our batteries to store grid energy. And we have a product called the Power Wall, which does that in homes, and also a product for utilities and commercial customers. Those are using new batteries, however. We've looked at reuse, or kind of the second life of automotive batteries for grid applications very, very closely. And ultimately, every time we've studied this, we come to the conclusion that it's not a very economical or very good use of those assets. By the time they come out of a vehicle that's lived its life, the technology will be quite old. We expect 10, maybe 15-year life at a minimum from these batteries. And the degradation is not entirely linear. By the end of their life, the efficiency has degraded. On every cycle, you see lower efficiency. The capacity will have somewhat degraded. And for a lot of reasons, it makes it very difficult to deploy those efficiently back into a grid setting where you want high reliability and you do want predictability. So, my view is that we'll see, new batteries dedicated to that market that also have slightly different characteristics. They should have higher cycle life. In an electric vehicle that has, 200 plus miles of range, you don't need as many cycles as you do on a battery that's designed to charge and discharge every single day on the grid. There's perhaps about a factor of 4 or 5 difference in the cycle life. So that's one aspect. To your second question about using vehicles as a buffer for renewable energy, this is definitely something that's coming, and I think there's 2 ways to implement this. The first is to use dynamic charging, and this is essentially intelligently commanding when the vehicles absorb their energy from the grid, to match up with when you have renewable energy available or cheap. This is something we can do very, very easily with just essentially software and controls. We don't have to change any of the hardware, and there's no additional regulatory or certification work needed. It's just essentially controlling the timing of when something would otherwise happen. If we want to actually send energy back from the car to the electricity grid, this gets much more complex. And that's something that I don't see being a very economic or viable solution in perhaps ever, but certainly not in the near term. The additional wear and tear and degradation on your vehicle battery has a fairly high cost. And many of the people and small businesses looking at this today don't take into account fully that degradation cost and also the additional interconnection cost. Because if you interconnect your vehicle, you do have new regulations that play a part. It has to interconnect in the same way that a solar system would on someone's home or on a business, which have different standards so that they can protect line operators and people on the grid.
And batteries and cold climates, do they go together?
Well, there is a lot of innovation happening on the ways to heat the cabin in an electric vehicle. And today, it's quite feasible to just use the electricity directly to heat the cabin, just with a resistive heater. But there's also heat pump technologies, which are improving substantially, especially things like CO2-based heat pumps. They can operate efficiently even in very low temperature environments. Overall, though, the impact on the range of cabin heating in these very cold climates is a little bit less than I think many people expect. And as you have longer and longer range on your vehicle, it's a lower percentage of the overall impact. If the vehicle only has perhaps 50 or 60 miles of range, the amount of the percent of energy that can go to heating the cabin is very substantial. But if you have 200 or even 300 miles of range, that percentage drops substantially because the amount of energy to heat the cabin is roughly the same for any given vehicle. Perhaps better insulation on some, but more or less it's a fixed amount. And as the battery gets bigger, the percentage of variability in your range drops and you have less impact on the customers. So today we see Norway as one of our best markets for the Model S. We have Model S vehicles that are above the Arctic Circle in Norway, and customers that are very, very happy using those vehicles in that climate. We even have charging stations in Norway above the Arctic Circle, so people can drive all the way from the northern reaches of Norway down into Central Europe. And in some ways, the electric vehicle offers an interesting advantage in that you can preheat the cabin of the car in cold weather. And we've seen customers that just love this feature where they can use their smartphone or their mobile device to go on and connect to the car even before they've left their home or building and turn on the heating system very, very safely, even if it's parked in a garage, and warm up the cabin before they arrive. That's a wonderful benefit in cold climates, and it can make that experience much better. To your first question, I think about battery R&D and who should conduct such work. I don't think there's a single answer to that question. I think as electrification becomes more well accepted and a more critical part of many OEMs' roadmaps, they will naturally start to do more and more R&D in this space. Tesla today does a huge amount of battery R&D because it's very important to us. Battery companies are also driving forward a lot of the R&D happening in this space, as are materials companies that are supplying the materials into battery manufacturing. At the earliest stage, governments are involved, and we work with many different national labs around the world that are developing sometimes local resources or focusing on very early stage material science that might take quite a few years to be commercialized. So there's not any one single answer I see there. I think it's going to be a whole selection of different people investing in advanced batteries. And I think the same goes for the infrastructure as well. Tesla has taken a fairly direct approach, and we did not want to wait for public investment in infrastructure, and we decided to make very substantial private investments in infrastructure so that we could enable rapid charging and a comprehensive network for our customers. And we've built this out worldwide. And I think that may be a very sustainable way to continue to build that network. There's no particular reason in my mind why charging infrastructure has to be done publicly. I think that can be done by some combination of auto manufacturers or different entities that are making a business out of that model. Well, I think largely the existing policies, at least in the areas we're focusing in, are getting many things right. I don't think there's maybe as many examples that are immediately detrimental to innovation. Around autonomous vehicles, it's still so early that we haven't really perhaps encountered all of the resistance and how that might unfold. But I am beginning to sense that may be a pretty challenging space, and I think there's a huge diversity of opinions there on how best to regulate that and what to ask for. But today, there's really an absence of policies and rules in that space. Around charging, around the world, in many cases, we see, regulation not being a barrier in any way. There's a few markets where, perhaps, certain solutions are kind of pre-decided by regulation, and sometimes that isn't very helpful. And I think where standards tend to not have enough scope in their future expansion, that's one that can be a challenge for innovation. For instance, the power or current capability of a charging connector standard. That needs to have enough upward capability so that as batteries improve and as vehicles improve, they don't become limited by the capabilities of the standard. And we are seeing that as a potential challenge with a lot of the different worldwide connector standards that are being defined. It would be a bit of a cap on the rate of charging and on the time that people could expect to refuel their car if we can't evolve beyond those standards at some point.
So who goes first? Mr. Straubel.
Well, I'll jump in on the flying carpet question. I think, of course, we have to work within the constraints that we have, and there's a number of new startup companies and small people trying to innovate much more radically around what is the notion for the vehicle they're even trying to make. I've met with many fairly wild startup ideas, trying to build self-balancing motorcycles or, autonomous, buses and trucks that don't look anything like today's vehicles. But it is a challenge, and I think, these brand new concepts, often face yet another barrier of commercial acceptance. So it has to be a quite compelling, business proposition or product proposition to get the public to accept it. And at Tesla, we took a pretty pointed decision early on that we would, focus our innovation on the propulsion technologies and not try and be too radical on the vehicle side. Many companies that had come before were building three-wheel electric vehicles or kind of spaceship-y looking pod cars and things like this, and it kind of compounded the difficulty in getting customer adoption. And ultimately, many of those were not very successful. So, maybe that's a quick answer to that question. But the level of interest here has been phenomenal. I think it's really indicative of the amount of excitement in the whole space and the whole industry. from our point of view, from Tesla's point of view, I would just reiterate that we see the pace of technology innovation in this space and the pace of product adoption continuing to accelerate. I think the example we heard from Norway is a very good one of what can happen when you do start to approach price parity with gasoline vehicles. Adoption rates immediately soar into the same order of magnitude. And that's going to happen across the board as we see battery prices continue to drop, and as we see the core technologies that are necessary to make electric vehicles continue to decline. And also from the autonomous vehicle point of view, that's another somewhat parallel set of technologies, but also one that we see reaching maturity and reaching market readiness far sooner than I think many regulators and even many consumers are expecting. And it's going to definitely put a challenge on the whole ecosystem to figure out how do we best regulate that, how do we best manage the adoption.